Hi guys, Larry Feldman again. In this video, I'm going to talk about several ways to find the area of a triangle. So what I drew on the screen is a standard triangle with angles A, B, and C, which are in capital letters, and sides A, B, and C in small green letters here, and also an altitude from B, angle B, to side AC with a length of H. And there are three main ways to find the area of a triangle. And this should be a pretty short video and pretty straightforward. But the first way is the formula that most of you are probably already familiar with, which is area equals 1/2 base times height. Fairly straightforward. The second method is a formula like this. Area equals 1/2 BC times the sine of angle A. And we can also write this using any of the angles. So in this case we used angle capital A. We can also say it's 1/2 AC, side C, times the sine of angle B, so the angle in between A and C. And the third form is 1/2 AB sine capital C. And I'm not going to prove these, although they're pretty straightforward. They're straightforward proofs. The third way, and this is actually one of the most impressive formulas that I've seen in geometry. It's called Heron's formula, and the derivation is actually fairly complicated. So I'm just going to give you the summary. We have something called S, which is the semi-perimeter. And the perimeter of a triangle is just the distance all the way around. So the semi-perimeter is the distance all the way around, all divided by 2. And the area of a triangle is the square root of S times S minus A, quantity S minus B, quantity S minus C. A fairly amazing result, definitely not intuitive, but it is a very useful formula. Okay, so I'm going to clear the screen and let's do some examples. Okay, so let's test these three equations using an example with a right triangle. So let me just draw a 30, 60, 90 triangle here. And in another video I talked about the properties of 30, 60, 90 triangles. So let's just label this 30 degrees, 60 here, and 90 here. And let's label the vertices like this: A, B, and C. And the sides are little a, little b, little c. So the first equation was the area is 1/2 base times height, which is 1/2. The base is, let's put in some numbers here. Let's say this is 1, this is 2, and this is root 3, as we discussed in the video on properties of 30, 60, 90 triangles. So we have 1/2, the base is 1, and the height is root 3, so we get root 3 over 2. The second method, use this formula. Area equals 1/2 AB sine C. So substituting in the values, we have 1/2 times 1 times root 3 times sine of C. And angle C is 90 degrees here. So this is 1/2 times root 3 times 1. Sine of 90 is 1. And again, we get root 3 over 2. And we can also say that the area is 1/2 BC sine angle A, which is 1/2. B is root 3, C is 2, and we have sine of angle A, which is 30 degrees. So this is, well, these twos cancel, so we get root 3, and sine of 30, let's look at this, sine of 30 is opposite over hypotenuse. So that's 1/2, so that's root 3 over 2. So everything's consistent. Let's come up here and do the last case. Area equals 1/2 AC sine B, which is 1/2 times 1 times 2 times sine of angle B, which is 60 degrees. Again, these cancel, and we get 1 times what's sine of 60? Sine of 60 is opposite over hypotenuse, so we get root 3 over 2. 1 times root 3 over 2 is root 3 over 2 again. So notice, same thing. Here, 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 everywhere. Okay, now let's use Hero's formula. Clear this out. And let me clean this up a little bit. So this is B, Hero's formula. So first we need the semi-perimeter, which is A plus B plus C all over 2, which is 1 plus root 3 plus 2 all over 2, which is 3 plus root 3 over 2. Then we get the area is the square root of S, 3 plus root 3 over 2 times S minus A, which is this, S minus B, and S minus C. Okay, now this looks like a big mess, but it will simplify nicely. We get 3 plus root 3 over 2 times 3 plus root 3 over 2 minus 2 over 2. I need a common denominator to subtract the 1. 3 plus root 3 over 2 minus 2 root 3 over root 3. Another common denominator. 3 plus root 3 over 2 minus 4 over 2. Let's keep going. And we get 3 plus root 3 over 2 times. Now we can subtract these numerators. So this is 1 plus root 3 over 2. Again, we can subtract these numerators, which leaves us with 3 minus root 3. I made a mistake here. Yes, it did. Root 3. Oh, this is a 2 here. Sorry about that. Three minus root 3 over 2 times root 3 minus 1 over 2. Okay. This doesn't seem to be getting any easier, but I assure you it will. Having a little trouble here with my software. Okay, let's come back up to the top. Area equals square root. And then we've got a lot of things to multiply. So let's multiply the first two terms by foiling. We get 3 plus 3 root 3 plus root 3 plus 3 all over 4. And then we'll multiply these two terms. So we get 3 root 3 minus 3 minus 3 plus root 3 all over 4. And continuing on, we have 6 plus 4 root 3 over 4 times 4 root 3 minus 6 over 4. And now let's FOIL again. We get square root 24 root 3. That's the first terms, minus 36 plus 16 times 3 minus 24 root 3 all over 16. And let me get rid of this. Are we having fun yet? Don't answer that. Now we've got these cancel. We get negative 36 plus 48 over 16. Which equals, let's split the numerator and denominator. 12, square root of 12 over square root of 16, which is root 4 times root 3 over 4. Which is 2 root 3 over 4, which is root 3 over 2. Same answer again. Obviously, Hero's formula is not very effective. Well, it's effective. It's not very efficient in this case, but it still works. There are many cases where Hero's formula is the easiest way to find the area of a triangle, especially when you just know the sides and you don't know the angles. Anyway, that's it for now, and I will see you next time. Thanks.